Good afternoon, everyone. Guys, just going to do a quick weather video on the potential for a snowstorm across the Northeast on Wednesday night into Thursday. So what we're looking at right now is the 500 millibar vorticity map for the GFS, better known as the American model. And essentially what this map shows is it just shows the disturbances that are in the mid to upper atmosphere. So that's the way you can think about it as we go along. So for example, this piece of energy across Wisconsin is the same as this storm that's going to be impacting the upper Midwest and Northeast tomorrow, bringing widespread rain and possibly thunderstorms to the mid-Atlantic down into the southeast, and then snow on the northwestern side. This is not the storm I will be doing this video on. It is going to be the one over back towards the west. But just keep in mind that there is a storm that's going to be coming through, and we actually will see warmer temperatures as warmer air filters in due to the southerly flow out of the Gulf, out ahead of this area of low pressure. So it's going to be warmer on Wednesday across the Northeast. Thus, there's going to need to be some cold air coming in if we want to get snow, and that is going to happen. So anyway, back to this. So this piece of energy is going to move off. And then the piece of energy that we will be watching for our storm is this one back across the Pacific Northwest. This is Tuesday evening. So let's keep an eye on the time here so we know where we are. This is Tuesday evening. The piece of energy is back across the Pacific Northwest. Now, I'm going to move forward and just pay attention as it moves to the south and east, and then it's going to come back up to the north and east. There's a second piece of energy that's important too, so when it comes down, I will point it out. Okay, this is late Tuesday night. Now your piece of energy is across Nebraska. And if we move forward, we see that there is a band of snow that's already associated with it. See all this red. Wednesday morning. Now it is across, almost towards Illinois. And our band of snow is starting to move east as well as we go forward. Here it is, it moves east. Alright, let's keep going. And now the other part that we have to pay attention to is this back up to the northwest in Canada. This is what we call a trough, a shortwave trough. And this shortwave trough is going to move to the south and east, and it's actually going to be what brings us the cold air during the storm. Because it's coming out of the Canada from the Arctic. It will be providing cold air, and then this is by Wednesday afternoon. This is our piece of energy now across Illinois, Indiana, southern Michigan, these places here, and as we keep going forward, we see that our storm is starting to form along a boundary that separates colder air and the warmer air down in the Gulf. So as this trough comes to the south and east, and as this piece of energy interacts along that boundary with the difference of the air masses, it's going to form a storm. So now one of the keys to how strong the storm is, well, how strong this piece of energy is. The weaker it is, then the further south the storm will travel, because this piece of energy needs to be out ahead of this trough back to the north and west, otherwise it's going to get suppressed to the south and east. Right now, both the American and the both the American and the European model do show that this piece of energy will likely come out ahead of this trough. So that's in pretty good agreement right now. But also the strength of this trough will determine the strength of the overall storm. So the weaker the storm is, the quicker it moves and the less snow we get. So that is also something to keep in mind as we move forward. So here it is again. Now your trough is coming down. It's across the upper Midwest now. Your piece of energy that's creating our storm is moving to the east. And our storm is going to be forming right over Kentucky here, right along this boundary, along that piece of energy. And as we go forward there, now you see it's starting to pick up. Your low pressure is east of Kentucky. It's across Virginia. Now you see precipitation starting to pick up. You have snow across Ohio and western and central Pennsylvania. And this is going to start moving to the north and east. Now there's something I want to point out before we do that. This is today's run of the American model. Here's last night's run. Look at this. You have darker shades of red, and the energy is a little more well put together. So that's the difference between the model runs that I have noticed. The American model was stronger last night than it is today. As you see, there's not really any deep red at all, and the piece of energy is a little more strung out, which means it is weaker. So let's go forward and see. Again, it's still not exactly what I'd want to be seeing. Now, it's good, though, that it is out ahead of the trough. That's the good thing, that this piece of energy is out ahead of this trough. And just remember that this trough is supplying the cold air as this piece of energy moves to the north and east. But the problem... Alright, here's our storm. Okay, this is overnight Wednesday. You have pretty good amounts of snow breaking out to the north and west of southeastern Pennsylvania, central New Jersey, and Long Island and New York City. It's still rain in these places because the cold air hasn't filtered in yet. But the problem is this. See how the storm is all the way back? I keep clicking on it. You see how the storm is all the way back here, late Wednesday night, across Virginia? So there is a difference in how quickly the storm is going to be moving, because last night the GFS model had this. The piece of energy is all the way back here and it's stronger. Now that's what you want. You want it to be moving slower and stronger. Look, notice there's more deep red. So that's the problem. If you look at the old run, 1,000 millibars, that's also a lower pressure than today's run. And then look at this. We go down to 997 on Thursday morning, and look at this heavy snow that's breaking out, even up into the lower Hudson Valley towards Albany, and then even into central and northern New England. Boston would be getting in on this. Philadelphia would be getting in on this. DC would be getting in on this. Well, actually, they might be a little too far south of the cold air. But anyway, that's the idea. Now, if you look at today's run, see, it's all the way out to sea already, and its lowest pressure it reaches is 1,000. So that's not what you want to see. You want to see it moving slower, and you want it to be stronger. So here's last night's run, and here is, if it would load, here's today's run. See? More strung out, less deep red, so it's weaker. And it's a little further east. So that's just the general overview of the dynamics that are associated with this potential winter storm. I would like to wrap up this video in the next minute. So I'm just going to essentially draw my threat area with my mouse here. And my threat area, because there's still a lot of uncertainty with this storm, this is going to be a wide area. So in the previous run, if there is a stronger storm, if that solution comes to fruition, then snow will be getting as far north as New Hampshire, Vermont, and southern Maine. So that's where I'm going to start drawing my threat area. It's going to go right through southern Maine. I would put Portland in that threat. I would go right through New Hampshire and Vermont. I would put Burlington in that threat, Burlington, Vermont. And then I'm going to come back probably right through Albany, across central New York State, and then going back towards Pennsylvania. Most of Pennsylvania will be in the threat area, including State College, and then Cleveland, Ohio should also be in the threat area. And I would bring this back down towards northeastern Kentucky, northern and western parts of West Virginia, northern Maryland. I would put Philadelphia in that threat, northern Delaware, and then ending in southern New Jersey. Not comfortable putting D.C. Well, actually, you know what? No. If the storm goes further south, cold air would come further south. So let's say D.C. is in the threat area as well. So that's it. That's the southern extent of my threat map. And Baltimore as well will be in that threat. So there will be variations with this depending on the track and the strength of the storm. Okay, thank you for watching. I'll post another update tomorrow.